Hello children, welcome to channel Sube. Children, today I am going to discuss question number 39 from the MCQ part of 2021 Physics New Syllabus paper. A sound source capital S emits sound of constant frequency f0. An observer O travels in the direction shown at a speed of 0.1 times u, where u is the speed of sound in air. Which of the following gives the correct relationship between f0 and the frequency f of the sound heard when the observer is traveling towards the source? So children, let us try to do this. So children, in this problem they have given this source somewhere aside, by the side of this straight line, not on the path directly. If it was if it were like this, we would have solved it easily, but they have given some distance by the side of the path. So therefore, let us first of all recall our knowledge, that means our lesson. In the classroom, what you learn is not something like that, but what you learn is both are on a straight line. So first we draw a straight line like that. Then source, suppose it is a speaker like this. So the observer, imagine like this. So he is moving towards the speaker, the source, with a velocity we say in the classroom we say u. So the sound waves like this moves towards the observer. Sound waves, you have to draw sound waves like this. You can't draw sound waves like this. The velocity of sound waves normally we take as v. The frequency, the real frequency is f0. So the frequency, this one is normally we write in the classroom this one observed, the frequency observed, this one frequency of the source. Normally we write these symbols. So what is the equation? Before the equation you should know if this observer is moving towards the source, the relative distance between them decreases, then this observed frequency must increase. So that is what you learn under this what effect, what we call this Doppler effect. Under Doppler effect, we learn at the beginning itself, in such a case the frequency increases. What is it? If this observer moves towards the source, even though the source moves towards the observer, the same thing happens. The frequency, observed frequency, is increased. That you learn using the ripple tank. Your teachers must have showed you using a ripple tank like this. We can show it that these frequencies must be increased. How we show it? Using a burette. We have to fill it with water, and the tap is here like this. So we have to adjust the tap so that 2 drops per second is released. So that 2 drops per second is released. So we first keep this at rest, this burette. First keep this at rest, that means we just hold it using our hands. Then we can see the wave fronts like this, circular wave fronts. They are with equal distances. This distance means what? Lambda. is distance between these wave fronts is lambda. So since both sides have same lambdas, so imagine that here is an observer, so he feels these waves. So and also there is another observer here, he also feels these waves. So both are experiencing this lambda same, and therefore frequency also same, FF. But if we moved this burette to the right like this with a velocity u, we just move holding it to the right. So we see the wave fronts appear on this wave front, appear on this water surface of this tank is like this. Is like this. These wave fronts are packed at the front and loosened at the rear. So like this. So this wave, the source is moving this way to the right. So suppose there is an observer like this. So he feels smaller lambda values. So that means frequency increased, because V is same here and here. V is same, so V equals F lambda. So what happens if lambda decreases? Frequency must increase. Therefore, this observer feels a higher frequency. So if there is an observer here, so he feels lambda increased and therefore F decreased. So that is why we keep in our mind that if the source moves towards the observer, the frequency increases. Source moves towards the observer, the frequency must increase. So therefore you should keep it in your mind, the frequency must increase in this case because the observer is moving towards the source. So children, now let us simplify this question by placing this source exactly on the line that the observer is moving. So if the question is like this, if the case is like this, this one is the observer, this one is the observer, I draw a man for that. So this one is the speaker because this is the source. So if the case is like this, we must we can decide that the frequency must increase. That means F is greater than F naught, because they have given this frequency as F naught and the frequency heard is F. That is how they have given these symbols. So according to the symbols given, we know now according to these explanations, the frequency heard, this one is the observed frequency, but we can't use observed because the O is you get complicated with this 0. F0 they have given, F naught. So this one is the observed frequency. Observed frequency is higher than the real frequency. So this one is the real frequency. So I write in red observed frequency. This one is the observed frequency. So here I have written it in red color. So in this answers also I color it red color. This is the observed frequency, otherwise you get confused it. This one is the, they have changed even left and right. They would have written it without changing. They have isolated here F naught, but they have isolated here F. So that makes students confused. So F is the observed frequency like this. So this is the relationship. Now if the condition is like this, this is the relationship. So it is not very different, very much different as the original question. So let us suppose this relationship is correct for the moment. So f naught should be smaller, f naught should be smaller. So this one says the same thing, f naught is smaller, this one, f naught is smaller. So here also f naught is smaller or less. Here f naught is not smaller, that is they have said it is equal. So let us keep them aside after this. After discussing this, let us take them later. So for the moment, let us keep these equal statements aside. So this one also might be correct because f is smaller. So there are 3 now. So now let us go to the real question. So let us keep this relationship aside. So this one is not on the line, on the straight line. So this source is somewhere by the side of the path. So this path is a straight line. That is the real question we have. So what is the difference than what we have received here? The real path is this one, but the equation for such a case is f equals v plus u divided by v. So this one is the original, this one is the equation with original symbols, but I have to change it a little bit because they have given some other symbols. So for such a case, this is the equation. Such a case means the observer moves towards the source. So when the observer moves towards the source, this bracket parts comes at the numerator like this. So we have to write it now. Instead of v, we have to write u because they have given u is the speed of sound. So here u and here u, then plus, instead of u is the velocity of observer. So the observer's velocity is given as 0.1 u. So we have to write 0.1 u like this, if not. So if we simplify this, we can take u out of the bracket, so it get cancels with this u below the line. So 1.1 we get in brackets and times f naught. So 1.1 f naught is the answer. The hertz, the frequency, the observed frequency. This one I used previously, red color. So this frequency is equal to 1.1 times f naught. But that happens if this observer were on this line, but he is not. It is not on the line, it is by the side. So we have to therefore use, instead of this 0.1 u, let us check what we can do. So actually the direct straight path is, if we draw the line to get this source to the straight path, so this is the line. So we have to now turn this velocity towards this way, because now the equation is valid. But previously, even though we substitute the values, this equation is not valid because this source is somewhere else, not on this line. So to make this equation valid, we have to turn this velocity to get it onto the straight line connecting the observer and the source. So what is the value? If this angle is theta, we have to get the component 0.1 u, that is cos theta. The component is 0.1 u cos theta. That is the actual velocity we have to use in the equation. Not 0.1 u, because it is just passing away by the side, but directly towards the source, the velocity is 0.1 u cos theta. So we have to, if you calculate correctly, you have to write like this: 0.1 u, not only that, cos theta divide by here it is not v, we are going from this step, so from second line. So this one is u, this one also u. What we change, just instead of 0.1 u, we write 0.1 u cos theta, because previously we assumed that this this source were on this line, but actually it is not on the line, it is by the side. So therefore we have to get the velocity. We can't move this one to this way, but we can change the velocity to this way. So we take the component, therefore. So the component is 0.1 u cos theta. So now we get the real value. So so you know, if we get the cos theta of something, it is, the answer is, the result is less than the original one. Therefore we get 1 point something less than 1.1. So here we have to write something less than 1.1, because we take cos theta of this value. If we take cos theta of any value, it is less than the original value. Therefore we get the result less than 1.1 f naught. So therefore, since there is an angle, the value must be the frequency experienced or frequency observed, the red f, must be smaller than 1.1 f naught. This red one must be smaller than this one, not equal. You can't get the equal value, because always there is a theta. Even though it came closer to this one, the theta is not vanished, the theta is still there. So until there is a value for the angle, the cos theta we must take until we get the cos theta, so it is less than, not equal. So therefore this one is the final answer, that is correct, that is goes with this our calculation. So this one has equal or smaller. So therefore the equal part we can't say it is correct, because theta is there always. If there is no theta, then you can say like this one, but until the theta is there, you have to choose this one, small, always is smaller than 1.1 f naught. So the answer is second one. So I think you can understand this. It is little bit difficult, I think confusable, but I don't know, you might understand, because the key is, if you get cos theta, I can write this, the original value is 1.1 u, that is the original one. If you take cos theta, that value is smaller, 0.1 u cos theta is less than 0.1 u always. Even though you take the sin theta, that also the same, smaller, less than. So this part becomes less than 0.1. Therefore the total value is something like this: 1.05, 1.04, 1.09, something less than 1.1. That is why I said that f is smaller than 1.1 f naught. So now I think you can understand if you didn't understand previously. So children, let us now do some target questions. Some target questions. Let us check first of all this 39, question number 39, whether it is correct. Yes, second one is the answer. So we have selected the second one. Previously, using this statement without going to the equation, we decided that this relationship, that means the left side of this one, only the left side without the equation. So using the equation, we decided this right side is like this. So let us now go to the target question. So children, this is the target question. So I don't read the question because there are some traps, so you have to find out what are they and face the problem by yourself. Therefore I don't read the question and I don't show any traps and I don't give any clues. So you have to now pause the video and start solving this. I think you have finished. If you use the equation, we have to connect this observer and source and get the velocity along that line. So this way the component of the velocity of the observer we have to get, because that is what we have to use in the equation. We can't use any velocity. We can't use any velocity given. So what is the component to this way? 0.1 u cos 60. The component is this one. So 0.1 u cos 60 means half. Then half of 0.1, half times 0.1 is 0.05 times u is the component to this way. So the equation is F equals u plus this one 0.05 times u, because the component we have to use here, then divide by u times F naught. This one emits F naught frequency. This one experiences F frequency. So simplify this, then we get F equals, u cancel, we can take u out of the brackets, then 1.05 times F naught. So this is the answer. So now the answer is this one, third one. You can be happy if you have solved it correctly. So children, now this is the question, target question number 2. So you have to read the question properly and you have to try this on your own. Pause the video and try to do it on your own, and after a while I will show you how to do it. Don't watch the video. I think you have finished. You have done it. So here what they ask is at the shown place. So exactly when this observer is passing this place, we have to find out the frequency. There is no range, therefore only one frequency is there. So in previous problems they had asked when the observer is moving along this line, not a proper place they have pointed out. So here they have pointed out that this place, exactly at this place. So we have to use the correct equation. This observer is moving away. observer is moving away. If the observer is moving, the equation is f equals the bracket term as the numerator, then v, then f naught. If it is moving away from the source, so you can see it is moving away like this. If it is moving away from the source, the frequency must decrease, therefore here v minus u should come. But instead of u, you can't use this value because it is not away, it is by side. So away means you have to connect these lines, this observer and source like this, connect using a straight line. And away means if it goes this way, it is away. If it comes this way, it is towards S and away from S. So now you have to get the component of this velocity because we have to use this one now. So what is the value? What is the component? Because this 60, so this one is opposite exactly, so the angle is also 60. You can mark 60 here. So the velocity this way, away, away. The velocity is what? 0.1 u cos 60. Cos 60 means half, then 0.05 times u is the velocity to this direction away from the source. So here our equation, we have to convert it to match the problem. Instead of v, they have used u, here also u, so minus, because still the observer is moving, source is fixed here at rest. So since the source is moving, the bracket parts comes to the numerator, so the minus should be there because when it is moving away, the frequency should decrease. Therefore since this one is the numerator totally should decrease, therefore the minus sign should be there. So instead of u, we have to write now 0.1 u, no, we have simplified value, let us used 0.5 u times f naught. So we take u out of the bracket, so it get cancels with this denominator u. So 1 minus 0.5 we get. What is the value after simplifying? 0.95. That is the final answer. We don't have to find any range because there is a fixed value, because they have asked only at this place. Therefore 0.95, this one is the answer. The fifth one is the answer for this target question. So children, what happened to your answer? Is it correct? So it is correct, then you can be happy, you are good, you are genius. Now children, let us face the target question number 3. So you have to read it on yourself and also find the answer on yourself without my help. So pause the video, don't watch the answer, don't watch my answer. You have to find out your answer, and after a while play the video and you can see how to solve it. Now I think you have done. So children, what they ask is the relationship when the observer is passing the source and beyond that. First let us find the answer when it is passing the observer. Passing the observer means exactly at this place. So approaching like this and at this place passing. So at this place it is exactly perpendicular. Therefore no components we can get. We can't get any components. If it was here, there is a component. To this line, a straight line connecting the observer and the source. So there is an angle theta. So if there is an angle, there is a component. But here the joining line is like this. So the angle is exactly 90 degrees. That means perpendicular. So if you take cos theta, cos 90, that is equal to 0. Then therefore this is, because cos graph is like this, 0. Therefore the velocity is 0. The velocity is 0. So if there is no velocity, the frequency must be same. If there is no velocity to the observer, that means observer is stationary. So this one feels as if the observer is stationary at exactly at this place. After that it changes, but exactly while it is passing, the source feels as the observer is stationary. So therefore frequencies must be equals. Therefore this one's real frequency is fm, but this one here is fm. So both should be equal. At this place it is equal. So let us keep it aside. So we can choose this equal sign. If there is a equal sign for the first part, we can choose like this, because there is an equal sign. So this one has not, this one has not, this one has not. So that is enough. Yes, that is enough, because there is no any other answers with equal. This one is not equal 1.1 times, even though the equal sign is there. So any other answers don't have equal sign. Therefore at this much we can finish, we can wind up the question. But let us do furthermore, because as an exercise in the real time examination, you can go to the next question, because they have not given any other answers with equal sign. So after beyond that what happens? This one is somewhere else, somewhere away, like this. Beyond that means so let us take like this. So somewhere away. So instead of, let us take a more simple instant, very far away. Very far away means you don't feel this distance. Then this little distance you don't feel when this observer is very far away. You can take to the same line, if it is only very far, because this angle is negligible. Then if it is only very far, you can take it to the same line, like this, very far. So what is the equation? So since the observer is moving away, so f equals, if the observer is moving away, the bracket parts is on the line, so like this. If it is moving away, the frequency must decrease. Therefore this one minus u, because this one should decrease, so this one also should decrease. Therefore minus, not plus, then times f naught. So the frequency is, so we have to use the given symbols. given symbols are like this, minus velocity 0.1 u. So u cancel, 1 minus 0.1. 1 minus 0.1 means 0.90 times f naught. So this is the frequency. We say frequency is decreased, but this is the minimum one. It can't go to 0. This is one. This is the minimum. Minimum. This is the minimum frequency. That means f naught must be greater than, not f naught. This one should be f. Here you see f. F. So that means f should be greater than this. This one is the minimum, greater than 0.90 f naught. Greater than means this one, greater than 0.9. We don't need this 0. 0.9 f naught, greater than. So that is the answer. Why we don't get equal? Why can't write equal here? Because this one is very far, I said. Very far means if it is only very far, we can neglect this length, distance. This distance we can neglect only if it is at very far. Very far means infinity. If it is at infinity, then only we can assume that this distance is 0 and take this to the same line. So it is not passing by, it is exactly moving away along the same line. Therefore, if it is only at infinity, then only we can solve like this, then only it is equal to this one. But if the observer is at infinity, he can't listen this sound. He can't listen this sound because it is very weaker, very weaker. 0, 0. He can't listen, so he can't listen this one. Therefore, we can't get that value, equal value. Therefore, we have to get this value. So a little bit higher than the minimum value. Little bit higher than the minimum value. So therefore, we can't use this one. We can't select this one. That is what I explained. It has greater or equal. We can't use this one. The first part also different, but we can't say it is equal. Only greater than 0.9 f naught. So I think your answer is correct. Then you are genius. And also, children, when I was calculating the first part, this one, so I selected this one, the equal one, but I didn't say why it is smaller than f naught. Why the apparent frequency, the frequency that is heard, f, that is the red one, the heard one, I didn't say why it is less than f naught, because I don't discuss this one, we have discussed it already, because this one is moving away. If it is moving away, the frequency must be smaller. Frequency, the heard frequency must be, the apparent frequency must be, that means red f, frequency heard by this observer must be smaller, less than original frequency, the real frequency. So that is why this term we consider as it is smaller than f naught, and also equal, small and equal, less than and equal, both. Now children, let us face the question number 4, the target question. You have to read the question and answer on your own without my help. Don't watch the video. Now pause the video and start. Children, I think now you have finished, you have done. So now I am going to try this question. So now the observer is stationary, the source is moving. So what they ask is the frequency when the source is passing the observer. When the source is passing the observer means at this point, so when it is passing, the observer doesn't feel any velocity because it is not moving this way away from the observer. It is not moving this way towards the observer. It is moving perpendicular. So if it is moving perpendicular, no frequencies change. So first of all, you have to connect the lines using a straight line. Connect the center points of this observer and source and checking whether it is moving along this line away or towards. So nothing is happening like that, and it is moving somewhere else that is perpendicular to the straight line connecting the observer and the source. If it is moving perpendicular to the connecting line observer and source, it has no effect. Therefore the frequency is same at this point. The frequency is same. The frequency heard is equal to the real frequency. It is given as f0. So that is the first thing. So there are equal answers, third one and fifth one. Here this equal. So after passing, what happens? After passing, the source is moving away. If it is moving away, the frequency heard is less than the real frequency. When it is moving away, it may be the source, it may be the observer, whatever, they are moving away from each other, the frequency must decrease than the real frequency. So therefore smaller. So after that is smaller. At the beginning it is equal. So the red one is the heard one, this one is the red one. You might get confused, so I have to turn this. That means I have to write f0 first, then it is larger than f. So here also I have to write f0 first. f0 is equal to the frequency heard. Frequency heard is written in red color. I have used like that. So here you have to compare, otherwise you can't compare. Difficult. You can compare, but it is difficult. So like this, these are the final answers. So you can connect these terms. How? Then you get this one. f0 is greater than f and also equal to f. So this one is the answer for the first part, and also this one you can select for the first part. Therefore we have to do further. Further means when this one is here. When this one is here, we can't use the equation. So we know the f0 is not f0, the f we have to discuss f. F is smaller than f0, that is correct. f is smaller than f naught, but how much is smaller? Can it be 0? If it is smaller, it can be 0 even. So we have to check that that is the right side. That is the right side. The smallest, the minimum value for, because it is decreasing, we know it is decreasing because it is moving away. Decreasing, how much? What is the minimum? So let us try to find out that. So we have to use equation for that. If this one is away like this, if it is not on this straight line connecting these center points, we can't use the equation if it is away like this. Therefore we have to take this source to the same line, but we can't take like that because the question is like this, moving by the side, not on the line. But if this one is very far away, imagine this one is very far away like this. I write very far away. That means infinity. If it is at infinity, you can neglect this distance. What distance? This distance you can neglect because this one is very large compared to this one. So you can neglect that distance if it is very far. So if it is very far, you can silently move it to this level, to the same line. To the same line you can move it if it is very far away. That means if it is at infinity. So then you can take this to the same line. Then you can use the equation. Because this distance is negligible, so they are directly moving away. So the frequency, the equation, what is the equation? So source is moving, when the source is moving, the bracket part is under the line, that means at the denominator. When the source is moving, when the observer is moving, the bracket part is above the line, at the numerator. So so the frequency must be decrease because moving away. To decrease, the denominator must be greater. The positive comes here like this. You have to, however, select the correct equation. This is the way I choose the correct equation by arguing. I don't keep the equation in my mind, I just write the equation at the moment by arguing. So the frequency must be decreased. To decrease the frequency, this denominator should increase. Therefore, not negative, it should be positive. So instead of v, in the question they have given u, then plus the velocity of the source is given as speed, and travels in speed 0.6 u, 0.6 u. So like this times f naught. So now you take out of the bracket and cancel, then 1 over 1 plus 0.6 times f naught. So 1 divided by 1.6. So I use the calculator, but you don't use it because you are not allowed. 1 divided by 1.6 to save time. 0.625 f naught. So this is the minimum. It doesn't go to 0. This is the minimum. F equals this one. So if it is the minimum, we can't, even though it is minimum, we can't use this equal sign because it is at infinity. If it is at infinity, we can't hear any sound. Therefore we can't use this equal value. We have to convert it a little bit greater than that, 0.25625. If not is what we hear, that is what we listen, that is what we hear. Then that means the frequency heard is greater than frequency heard is, that means red frequency must be greater than this value, 0.625. If not, it is not equal, because it is equal at infinity only. At infinity, when it is an infinity, we can't hear, so there is no such a value at infinity exist. Therefore, little bit closer than the infinity we have to consider. Therefore, this is the condition. This is the condition. So let us compare this with the answers. So 0.625 greater. Here greater and similar we can't use, therefore only greater. This one is the answer. Third one now. So there are a lot of arguments to get the answer. I think you can understand, because now up to now you have done 3 target questions. This one is the 4th one, final one. So children, I think you are happy. You must be happy, because I did lot of things for you. So please subscribe my channel if you haven't still subscribed. So press the bell icon also, and also press the thumb up icon also, and share my link with your friends also. Don't be jealous. I think you are not like that. So see you tomorrow. Goodbye.